everybody. So today we're going to be dealing with Trigonometry chapter 22, exercise 22e, question number 11. So this question states that there are three strong cables, and they are used to brace a 20-meter tall pole against the movement due to wind. Each cable is attached so that the angle of elevation to the top of the pole is 55 degrees. Find the total length of the cables. If you look closely, what I did is that I highlighted or underlined everything that is actually important and that you have to take from the question rather than reading all the question. So you have to take that there are three strong cables because we have to calculate the total length at the end, so we have to multiply it by 3. Even though you can look at the figure and say, oh, there are 3, but you still have to look at the question because it may be a possibility that they won't give the figure. So they're used to brace a 20-meter tall pole against the movement of the wind. Each cable is attached so that the angle of elevation to the top of the pole is 55 degrees. And then we have to calculate the total length of the cables. These are the important informations in the question. So first thing, it is written that we have to calculate the total length of the cables. So we don't have to calculate the length of each cable. We have to, but then we have to multiply it by 3 to get the answer. So once we know that, we can look at how we are going to solve this question. So we will look at only one of the cable, because if you look closely, both 3 of these triangle, this triangle and then this triangle and this triangle, are all similar and congruent to each other, because this is 55, this is 55, this is 55, this is 90, this is 90, this is 90, and this is 20 for all 3 of them. So it's just the same triangle. So if we calculate this length for just one of the 3 ropes, we can just multiply it by 3 and then get the total answer. So how will we get this length? So if you look closely in this triangle, first I would recommend you to label them to get a close grasp on the things that are going inside this question. So let's name this A, let's name this B, and let's name this C. Once you have named them, you can go ahead and say that in this triangle, this is a right angle because this is a pole and pole stands upright, and this is the rope is actually doing a job to make it upright and allow it not to move when there is wind. So this is 90 degree, and thus it is a right angle triangle. This is 20 meters. We have to calculate this length, and we have this angle. So if you look closely, this angle we know the opposite, but we have to find the hypotenuse. So if I write SOHCAHTOA over here, SOHCAHTOA is just an abbreviation to remember how to know which one we're going to use, sine, cos, or tan. So we know opposite, we know the angle, and we have to find the hypotenuse, opposite and hypotenuse. So we're going to be using sine. We're going to use sine to calculate the value of AB, and then we're going to multiply the value of AB to 3 to get the whole value. So now we're going to start the real question. So we're going to start with in triangle ABC, angle ACB is a right angle. Once you know that, you can just go on. If this is a right angle, then it's a right angle triangle, and we know that AC is equal to 20 meters, and we know that angle B is equal to 55 degrees. All of this is given, and then we can just move on and say, okay, we're using sine because we know the opposite and adjacent. We have to find we know the opposite and we have to find the hypotenuse. I'm so sorry. So we're going to use sine, and we're going to say sine 55 degrees because that's the angle that we're looking at. This angle is equal to opposite upon adjacent. Opposite is equal to AC, and opposite upon hypotenuse, AC upon AB. Why am I getting it wrong? Okay, AC upon AB, that will be equal to, AC is 20 and AB is We don't know AB, so we're just going to write AB. We're going to take AB on this side. We're going to write AB is equal to 20 upon sine 55 degrees. If you calculate it, it would be approximately 24.41 or 42 meters. So you can calculate it, but what would be better is that you multiply it right over here, because we have to calculate the 3 ropes. So we will multiply it by 3. That will give us the value as 73.2 meters. That is 24.42 or 41 multiplied by 3. And that's it. Thank you.